Yep. Okay, that one. Okay, so thank you for that. So today, what we're going to be talking about is a platform that we've invented called Archisto, and the idea is it's a set of technologies and tools for building digital repositories. So the point of this presentation is that we're going to be talking about managing fair digital objects throughout their life cycle. So in the last couple of years, what we've been doing, both myself and the Paradisic team, which I'm a member of in the University of Melbourne, and the folks at UTS, we've been thinking about how you manage digital objects throughout their lifetime. And this is a schematic that Peter and I came up with a little while ago, saying that when it comes to managing research data during its life cycle, researchers want to be able to use their own applications in their own way. But those applications aren't digital repositories. The data is not safe. So that's what we sort of think lives in the workspaces bubble on the left, the red bubble. That can be any sort of tool that the researcher or the community that the researcher is a part of says, well, this is what we use to do our work. And within those tools, they will collect data, they will analyze it, and they will describe it. They'll have cleanup processes. But their data will be ephemeral. It will be dirty. And what we're saying is that there should be a process that, it's a process where the researchers get used to actually depositing fair, well-described data objects into repositories regularly, and doing it early and doing it regularly, doing it often. And this is sort of akin to the software development model where, you're checking code often to the repository. You keep working on it on your own laptop, but you check it in often and you reuse it as you need it. So that's what we've tried to capture in this schematic. We're basically saying that the way researchers work actually needs to change a little bit. They can have whatever workspaces they want. They can use whatever tools that they want, but they need to get into a model where they're actually describing their data constantly, and they're putting that data into the repository, whether it be institutional or domain, and the data will then be managed according to the specific policies of that repository service. And when they need to reuse the data, they can pull it back out and put it into their workspace. So if that's true, the first question that we need to ask is, how do we actually look after the data? And when we say how can we first look after the data, we're talking about on the repository side of things. So if you're wondering what that picture of the dog is, that's I'll give all the credit to Peter on that one. Peter, when he first wrote a version of this presentation, he said, what is the emoji for a standard? And he had landed at standard poodle. So what we're saying here is we should be using standards. And the first standard that we actually suggest to be used is the Oxford Common File layout. So the Oxford Common File layout is just a standard for laying out files on disk, nothing more, nothing less. It gives you guarantees of completeness and parsability and robustness and versioning and storage diversity, which just basically means that your data is checksummed, it's laid out in a very specific way, and it doesn't require any services to be run for you to actually access your data. So what this actually gives you is the way to think about this is it's actually a storage layer that's independent of any services. If you use the OCFL and whatever services you're running on top go away, your data is still safe. So that's the first part of that answer. The second, we have actually started doing this in some work that we've been doing with the CS3 Mesh project in Europe. And what we've been saying is that actually from their perspective, in that blue box up in the top left, that's almost, a staging ground from their workspaces. So imagine that there's a red box above that, which is all their workspaces. So whatever the communities that are part of the EOS mesh, whatever applications they're using, the data is moving from their workspaces into this blue box, which is kind of a staging area, which in their case is OwnCloud. And then it's connected via a description service, all right? So that the users can then describe their data as they're actually collecting it, as they're analyzing it, as they're working with it. And then the description service can push those fair digital objects over into the repositories. And in the specific case of the EOS mesh, they want to be able to push to Zenodo. But there's no reason why the data can't be pushed anywhere else to any other repository or any other service. So that's the first part of it. But if you're going to be pushing data into these repositories and you're going to be storing it using OCFL, then what are you actually storing? And this is the second part of the equation that we've been thinking about and working with. And in this case, what we've got here is an example of a research object crate, which I won't go into in much detail because that's discussed in the next talk. But the idea is that with RO crate, you would say, this is the title of my data. Here's the description. Here's an identifier for it, which ideally would be a DOI. And you can say who created it, what parts does it have, when was it created, what is it about, how can it be reused, so on and so on and so on. Now, the beauty of RO Crate is you can actually, there is no set amount of data that you need to put in. You can just go so far as to describe a title and a description, which already makes the data more usable than without that. But if you want, you can actually go quite detailed and say, well, my data package has these files, and these files were created by this machine at this time, and the operator of the machine at that time was. So it's a really flexible model for describing your data. So if you take your research data and you build your systems, and then you say, okay, we will lay the data out on disk using OCFL, and we will describe it using RO Crate, then the question becomes, what does it let you do from that point? And this is sort of an idealized view of what we think the world should look like. Up the top, you have the red box, any workspace service, and that's supposed to indicate that the user community gets to use what is right for them. Now, it could be something they can get off the shelf. It could be RedCap instance. It could be an OwnCloud instance, or it could be something that they've built themselves. But the point is the researchers work the way they need to work and they want to work. To then tie that into the ecosystem, you have some kind of digital export service that knows how to read these workspaces and produce the digital objects into some intermediary staging service. So that would be the blue box in this diagram. And this is kind of a conceptualization of what the EOS mesh is doing, okay? Where the blue box is an OwnCloud instance. So you export your data to the OwnCloud instance. It's integrated via a description service that then allows you to push it to a repository. And as you can see, there's a cycle here. The data can always, there's always new data coming out from the workspaces that's being exported. The data is going into the staging area in the EOS mesh box in the blue, and it's going through that cycle of describe and publish, describe, publish, or upload to repository. So if you accept that, then if you zoom out a few more levels, if you go higher up, if this is maybe the 20,000 foot view, and now you can see these blobs, the red blob and the green blob. And you can see that actually this slide, there seems to be some things missing, like none of these things are tied together. And this is, the issue here is that you end up tying together the services that the researchers want to use with the repositories, but there's still things missing. Ideally, from a researcher perspective, you would want to be able to say to them, go to somewhere, and then from there you can provision what you need in your workspaces. You can provision the connectors that you'll need for your workspaces to publish to your repositories. You'll be able to do your authentication, your authorization. You'll be able to do group services. You'll be able to determine and decide who should be allowed to see your data. You'll be able to do licensing. And as you can see, these things aren't linked together. So there's still bits that need to be built in the ecosystem, because ideally what you want from a researcher's perspective is you want something that looks like this. Now I'm going to hand over to my colleague, Michael, and he's going to talk through this and then come back to me.
Hi, everyone. So this is a diagram of the system we've been working on at the University of Technology, Sydney. It's the hub in the middle is our research data management planning tool and research data catalog called Stash. And that's where researchers go to create research data management plans, but also to provision or get access to various kinds of research infrastructure. And that's the stuff around the circumference. So we have RedCap surveys, lab archives notebooks. We can give them access to a dedicated GitLab facility we've got for research code. And this is a future state thing. Some of these services we haven't yet attached, but the idea behind it is that the integration here is pretty loose. So what happens is if you want to spin up a GitLab, it uses the GitLab API to create a project in GitLab, which has a token which links it back to the research data management plan. These things will still, similar to what Marco was saying about OCFL, these things will still work independently. If we replace our research data management planning tool with something different, it doesn't take away access to all these other services. And we're using, you can see up in the top left, there's a link to our data portal. That's where the system also includes a publication workflow, which pushes out to an OCFL repository, which has a Solr index on top of it that lets people search for data sets in our data repository.
So once you do all of this, then you're starting to build a cohesive, I guess, what looks like a cohesive application for the research community that's built up of pieces that are ultimately interchangeable. And if the pieces are interchangeable, but the data is safe and secure in a standard format, then you don't have to go through a data migration every time you have to evolve the technology stack on top of it. So
I'll just hop in. The other thing we're doing with that system is the ability to export from the specialized formats or from things like lab archives where it's off in the cloud somewhere, export it out to an RO crate, which we can then keep, and it retains the metadata and doesn't leave our data trapped in services that we might not use for the next, might not be using lab archives in 5 years from now.
So hopefully we've made clear that, you know, the data, once the data is safe and sound in standard formats and in standard systems, then the services can evolve. And so this is an example of what we've done so far. In the top left and the bottom left are screenshots of the modern Paradisic demonstrator, which is a single page JavaScript application running with an OCFL repository on the back end that currently has about 70 terabytes of data in it. But it remains performant and scalable because it doesn't, you know, the way the OCFL works, you don't get, it doesn't slow down as the amount of data increases. And on the right is the ONI application showing the library of successful grants from UTS. And this is also a more generic viewer of an OCFL file system. So we're actually doing this in the real world. We're not just talking about this as an idea. So we've done lots of tools. There are specs to go and read. There's lots of things you can play with. I won't go into this in detail. Probably the only thing to be aware of is UTS wrote a reference tool called Discoverability, which allows you to create RO research object crates. It's a desktop application for all the major desktop environments, and it allows you to package up a folder with an RO crate file and ship it off to somewhere in a baget form or a zip file. And finally, to wrap up, we're documenting all of the things that we're doing here at this site that we built, the arkistoplatform.github.io. So if you want to see what we're doing, if you want to read more, some of the patterns, some of the standards and case studies, have a look there. So thank you.
Thank you for that, Marco. Are there any questions from the audience? Please use the Q&A functionality in Zoom for that. Not seeing any come through at the moment. It is really exciting to see so many poodles in here, so many standards, and taking advantage of those. Still looking like there might not be any questions coming through. Given that the next presentation is quite closely linked in terms of paper, if people think of a question for Marco further down the track, just feel free to pop them into the Q&A. Before I hand over to Peter for the next presentation, I should actually stop my timer because Marco was fantastically on time. So I better go and make sure that I don't confuse myself further down the track. And I should also still put in a few housekeeping notices. Some of you might have noticed I've popped a message in the chat to say that we do have a code of conduct in place that we're expecting everybody to stick to. There's a link in the chat with more information, and if you notice any violations of the code of conduct, please do let us know. Another quick note that we have reordered the talks in this session slightly, so the last two talks will be swapped in order, with Masashi speaking first, and then we will have a recorded presentation from Tanya as the final presentation in this session. And just another reminder again to keep using the Q&A box in Zoom for any of your questions. Rightio. There have been no questions turning up in the meantime, so I shall now hand over to Peter from the University of Technology, Sydney, to give an update on the research object crate, and I believe this is in collaboration with the University of Manchester.
Yes. Sorry, I'm just trying to work out the screen share. We tested it and everything.
The bottom menu.
Yeah, so
No.
I'm just finding one of my 400 windows. That should be it.
Yes.
Okay, so this presentation I prepared with my colleague Stian from the University of Manchester, but there are also more than 40 people involved in this work, so it's really a collaborative effort that I'm talking about here today. Change slides. Okay, so we saw a quick preview of this slide before from Marco, but I'll go into it. Well, I'll expand a little bit on what Marco said. So, what is a research object crate? I'm going to research object. The RO crate was introduced at Open Repositories in 2 years ago. So some people have seen this before, but we do need to explain what it is. So we're going to have a quick tour of it. 2 years ago, we were talking a lot about data packaging. So the emphasis was on being able to grab a whole lot of files and put them together into something that you can then zip. Add checksums using Bagit and distribute. But it has evolved a bit since then into being a more inclusive way of aggregating resources. So it can include local data, but it can also include anything that is addressable over the internet. So the core of an RO crate is a metadata file in JSON LD format. So that's JSON linked data. And the idea is that you describe everything that's useful to the community that you're trying to work with about the data. So obviously we have the usual who, what, where metadata, which you're familiar. Everybody in the repository world is familiar with the sort of Dublin core. A few elements: titles, descriptions, identifiers, and who created the data. The difference is that we have an emphasis on linked data. So we basically describing things with strings is banned as much as possible. You don't just type in someone's name with potential typos or misspellings or variants. You actually include an element for a person and identify them if possible with an ORCID. Although there are spaces where people won't have, like, look, going back to the keynote, if you have Indigenous participants, they will have other ways of being identified or not identified. But it's a mesh of linked things, including the example at the bottom, important information for reusing data, if we're talking FAIR, findable, accessible, interoperable and reusable. What machines were used, what settings were used on the machines, what lens was used on the microscope, that kind of thing. And also, with the recycling symbol in there, how can things be reused? Everything must have a license. So we do distribution of data based on licenses, and the RO crate spec doesn't have very many rules, but one of them is that every research object crate should have a license. Okay, so RO crate is omnivorous. I'm having fun with emoji again, but this is just designed to show that we can cover any discipline: meteorology, medicine, geography, geophysics, and it's not limited to just scientific stuff or any particular one domain. To expand a little bit on what it looks like, if you have an RO crate, it can be distributed as a zipped up folder. So if you download it and you open up the zip file, you will get, showing on the left of the screen here is a view of a file system. And then the RO-crate metadata file that sits beside that in the root of the crate actually describes each of the, can describe each of the data elements that are the package with that crate. Now this is unusual, and we kind of had to invent this because most metadata that gets shipped around with data, if you're lucky, you would get a README file in the root of a zip file that would tell you in general how what's in there. But there were no formal ways a few years ago that we could find that actually let you say, okay, that JPEG file there, 2021-04-08, what is it? So this, on the right-hand side of the screen here, is a JSON format way of describing that file. So what size is it? What format is it? But importantly, providing a human-readable gloss of what's actually inside there. And I know you want to see the cute puppy. So these also, inside the RO crate, you can have, it's not compulsory, but it's highly recommended. An RO crate can also contain an HTML file or files, which is a static website that describes the data. So alongside the data and potentially descriptions of that data that are machine readable using the JSON, you also have an HTML view in there, and that is where you can actually see a preview. So if it's a PDF file or something, you can actually look inside it from that HTML file, and you can see a picture of the dog, who has actually just started snoring right beside me. And importantly, if you have a picture or that's come off a microscope or from some field work or something, it's really useful for people who want to reuse data to have good provenance. So a good solid description of what, how the data was created, using exactly what tooling, what software, what physical instruments. So using the linked data JSON LD, you can describe provenance. And the way we do this is RO-crate uses a vocabulary called schema.org, which was invented by the web industry, Google and Microsoft and others, to help them extract semantic information out of web resources. So things like movie times, structured information on the web, opening times for businesses and so on. But we can also, because it's a very general purpose schema, we can use that to describe the provenance of research data in very general terms. Now there are some domains where this is not enough. Being able to just say this chart was created using using a particular piece of software is not enough. But for a lot of data, that would be enough to help people to know how to interpret and reuse it. As I mentioned before, RO-crate is compatible with other technologies that compress, package, and distribute your data. So it doesn't do any of those things. It works with other things. So it works with zip, as I mentioned before, or you can use tar or other packaging disk image formats. And it is compatible with other standards such as Bagot, which is widely used in our community for distributing packages of data, but which doesn't have any metadata to speak of. It has very limited metadata. So RO-crate can provide the metadata that Bagot doesn't do, but it doesn't try to do Bagot's job, which is Bagot keeps track of checksums and has detailed manifests of what's in a data package. Right, so that was the intro. Now I'm going to update you on what's changed. So if you've been following along with this, the first RO-crate presentation in Hamburg looked at a marriage between a project we were running at the University of Technology Sydney called DataCrate with the research object work that was going on at Manchester. And the research object people were very much concerned with detailed scientific provenance and reproducibility. And the data crate people were concerned with things that were implementable by real developers quickly with simple, easy to understand specs. So Stian and I are the editors of this spec. Since we last talked, we've got to version 1.1. The main things in version 1.1 are we've stepped away a little bit from the packaging, as I mentioned before, and we're now have a more inclusive view of being able to have a crate which may have actually no content, but just aggregates other internet resources or even physical resources if they can be addressed. The tools have been developing rapidly, so I'm not going to go into this in detail. I'm just showing that if you go to the RO-Crate website, you can see lists off to, we've got JavaScript, Ruby and Python libraries, and there's a bit of work I'm involved in which will probably yield an R library. I've put in the same screenshot twice. I was meant to put in a link to a page which showed, this is the one. Some more data. This is the RO-Crate in use that links off to a number of different projects that are using RO-Crate. So I won't go through this in detail, but we will call out a few things. Going back to Archisto, which we just heard about, this is the Archisto page that looks at some case studies, and I've just put this in here so that you can make the link between the Archisto as a whole platform and RO-Crate as a specific technology piece of Poodle that goes in the as part of that. One of the new things that we've done in post version 1.1 is profiles. So RO-Crate is a very simple set of guidelines, really. It builds on other specifications. It is designed that you can sit down and just read and go and find examples of how to package data from various disciplines. And to help that, we've started working on this idea of a thing called a profile. Some profiles will be quite high level and might talk about things like what sort of identifiers should you do. So they would be advice. The profile for something like a fair digital object, if you want to talk about what makes data fair, will probably have a lot of high-level stuff in there about what is a trusted repository, what kinds of identifiers should you use, persistent identifiers, and how should you structure your services. Versus, so we're involved in this conversation with the FAIR community. And we're sort of coming at this from the bottom up. We have a working system that distributes data, and we're looking at writing the profiles that help people meet the FAIR goals. But then there are also much more specific things. So this is Workflow Hub, which is a bioinformatics platform which actually has profiles, has RO-Crate profiles under development, and they are very specific. So they will be machine actionable profiles that will let you validate a particular RO-Crate to check that you've referred to workflows in the correct way. So profiles will be a range of different things for humans and machines, and we don't have any that are really finished, but that's what some of the current work is doing. Bringing this back to the repository community, there are some very detailed conversations going on with the Dataverse crew, the Dataverse team, about using RO-Crate in there. I've got a screenshot here of Zenodo. Zenodo can ingest RO-Crates, obviously, because they can be packaged as zip files. But through the work that Marco and I are doing on the EOSC Mesh project, there will be some additional stuff put into Zenodo, which lets it understand RO-Crate. So if you deposit a crate, it will be able to understand the metadata, and we hope also display an HTML view of what's in your crate, so you can see the microscope images or the cute puppy pictures. And just to finish up, we conduct our business completely in the open. There's a GitHub repository, there is a Google Doc which is open to all, and the team meets every 2 weeks, or twice a month we meet. in a European-friendly time, or European morning and late European afternoon. So most people in the world should be able to get to one of the meetings, but they actually suit us here in Australia pretty well. That for once, in international collaboration, that's a bit unusual. So we'll leave it there. We would encourage you to, if you liked what you heard here, come and join us, come to a meeting and tell us about your requirements for moving around digital objects.
Thanks for that, Peter. Spot on time. You avoided my phone's buzzer sound. Well done.
21 seconds left.
Yeah, awesome. We have one question from the audience from Vanessa Crosby asking whether you are minting Pids for your instruments.
Okay, so no, that would be something you would consider. That's not an RO crate concern. So RO crate, if you have a PID for your instrument, then good on you. And RO crate will tell you how to include that in a crate. But RO crate is the way of describing something. It doesn't deal with that. We will be dealing with that in some of the tooling. So the Archisto platform, that will definitely be, being able to look at what might make a good instrument registry for people who don't have one would be something we'd be considering as a really core use case for the broader Archisto way of approaching research data. But yeah, the minting part is outside of the scope of the packaging description part.
Thanks, Peter. We've got another question from Tomasz Neugebauer. Sorry if I mispronounced that too German. In our crate, does addressable resource imply anything about the stability or required access permissions of the resource at the address? Can the license of an addressable resource be unknown?
That's another very, very good question. To answer I think there's kind of two parts of that. So one, I guess we just follow the web norms for this, which is, you can address things using URIs or URLs, but there's never any guarantee that they will be, they'll be available. So the core RO crate spec can't really say much about that. But coming back to profiles, if we have a profile for fair digital objects, or we have a profile for use in a particular domain, it could say something about what in your domain, for your discipline, what are permissible or recommended things that you might want to link to. And I don't think the question was quite asked. The question about licensing, I just wanted to say something about filling in the gap that Marco showed. So Marco showed a diagram which showed repositories and workspaces and authorization systems as being like disconnected blobs and called essentially for more work. One of the things we're looking at is within an RO crate, if it has a license, we would like to be able to have, every crate should have a license. That part of that should be human readable, so that in a preservation situation in 100 years, an administrator can read the license and work out what should happen to a piece of data. And if you find it lying on your hard disk, you can read the license and interpret it. But licenses could also have URLs. And we're looking at an infrastructure where those URLs, certain repositories might trust certain services and allow them to do the authorization step, which would mean we could disconnect the authorization from the repository and have a community set up an authorization service. Particularly, this is going to be really important in work we're doing with Indigenous and language data. Allowing communities to sort of specify their own rules and norms and policies, but repositories might be able to, using a scheme, something like OAuth, be able to not have to worry about that, but hand that off to other services.
Great, thanks for that, Peter. I think with this, I can hear the dog barking in the background, so there's proof that it's not just cute pictures. Anyway, right. We shall now hand over to the next presenter, which is Masashi Kawai from the National Institute of Informatics in Japan, who will be talking about a causal analysis of the progress of green open access. Over to you, Masashi.
Okay, let me start my presentation. I'm Masashi of National Institute of Informatics in Japan. My presentation is about causal analysis of the progress of green open access. So this presentation consists of these three sections. Six sections. First, let me talk about the background and the objective. About 800 institutions are on IR in Japan, and most of them use IR only for PhD thesis OA because it became mandatory in Japan. Therefore, they are asked to use IR also for Green OA by Japan Consortium for Open Access Repositories, JP Core, which is the largest IR consortium in Japan. But no effective library operation to boost Green OA is introduced by JP Core. This situation makes it difficult for them to boost Green OA systematically. Given this background, we set one objective, which is to find an effective library operation to boost Green OA. But this objective is too abstract to start research. So we set a more specific objective, which is to calculate each library operation's impact on Green OA progress. The specific objective can be visualized like this green figure. There are operations A to X, and each operation has its own impact. By calculating each impact, we can find an effective library operation. In this case, operation F's impact is biggest, meaning it is effective to boost Green OA. Once operation F is found effective, then we can boost Green OA by spreading it among institutions in Japan. Next, let me move to data. We need data for these green circles of the figure. As for operations, we used questionnaire survey data. We made this data by ourselves. And as for Green OA progress, we used two data. One is Web of Science, and the other is institutional repository database, which harvests metadata from all the IRs in Japan. So we used three data in total. We merged these three data into one matrix to apply algorithm and calculate impact. Basically, elements in the matrix are supposed to be numerical. So we filled the matrix with numbers. As for operations, if answer in the questionnaire survey data is yes, we put 1. And if answer is no, we put 0. As for Green OA progress, we used this equation. The number of journal articles by AIDS researchers open access in AIDS IR is divided by the number of journal articles by AIDS researchers. This is a plot of Green OA progress. It turned out Green OA progress in Japan is averaged about 5%, but Green OA progress in some institutions are very high. So operation we are trying to find is something that can take Green OA progress to this level. The remaining columns consist of 15 library operations that are deemed relevant to Green OA progress. There may be more than 15 operations, but we think they cover most of the relevant operations. As I mentioned, there are about 800 institutions that own IR in Japan, but only 87 institutions are listed in all the three data. So rows consist of 87 institutions. Next, let me talk about algorithm. This section is not so important, so I will speak briefly. We need algorithm to calculate these impacts in the figure, and we use random forest. Random forest is a decision tree based ensemble learning algorithm. So random forest model consists of multiple decision trees like this figure. It can calculate each operation's impact, and we can get this kind of graph. Next, let me move to analysis results. This is the analysis result. It shows operations directly approaching to researcher, such as email service to request full text, or email service to notify downloads count, have a big impact on Greenway progress. Especially email service to request full text has a big impact. So we found email service to request full text is most effective library operation, and our objective is accomplished. But we also surveyed its success rate, because success rate helps us to understand what exactly its high impact means. Data from only 4 institutions were available, but we found an annual success rate averages 36%. So if you send 10 emails, you will get about 4 full texts. As for institution A, the annual success rate averaged 55%, reaching a peak of 73%.
You're at time now, so could you please just quickly wrap up?
Okay, next let me move to a summary. So the objective of this presentation was to find an effective library operation to boost Greenway. We found email service to request full text was most effective. We also found its annual success rate averaged 36%. So it is possible to say Greenway can be boosted by spreading the operation among the institutions. Finally, let me talk about the future tasks. I mentioned we should spread email service to request full text among the institutions, but actually it would be difficult because its flow is very complicated, as shown in this figure. So we did some interviews and found obtaining archiving policies, especially energy consuming in this flow. It is because shell format is not regularly updated, and finding archiving policy on publisher's web page takes time, and archiving policy is written in English. So to spread the operation among the institutions, it is necessary to make obtaining archiving policy easier. So we are developing support system as one of the functions of Agile Cloud. That is IR we have developed. To use this system, first you need to register your affiliation as a search query. In this case, University of Discoverability is registered. This is final slide. Once affiliation is registered, this system automatically provides this kind of information. Item circle green shows author mark and closed mark in addition to metadata. Author mark means you can register author manuscript version of this item according to archiving policy. Closed mark means this item is not open access in other place. So this item should be registered as a priority. In this way, this system helps IR staff or librarians. About 600 institutions use Agile Cloud in Japan. So we hope we can boost GreenOA with this system. That's all from me. Thanks for listening.
Thank you for your talk, Masashi. We don't have a lot of time for Q&A, but if there is something that somebody would like to quickly pop into the Zoom Q&A, go for it now. I do have a very quick question. I think the third factor, did you call it IR staff number? Is that the size of the staff for the institutional repository?
Yes, yes.
Oh, yeah, yeah. Yep. All right, here. Oh, no further questions have arrived. So we will now go over to the final talk in the session, which is a pre-recorded talk by Tanya Holm from the University of New South Wales in Australia, talking about next generation repositories best laid plans, which sounds a wee bit ominous. We will have Vanessa Crosby available for Q&A for this pre-recorded talk if needed. Thank you.
Hi, it's Tanya Holm from UNSW Sydney on Next Generation Repositories Best Laid Plans. UNSW Library is migrating its institutional repository to a new platform, DSpace 7. Confederation of Open Access Repositories, or CORE, published the first Next Generation Repositories report in 2017, identifying common behaviors, protocols, and technologies that will enable new and improved functionalities for repository systems. Since DSpace 7 is still in development, a prototype was developed for UNSW in 2020 and evaluated against CORE's guiding principles. In this presentation, I will outline some of the requirements that required compromise to illustrate the need to balance adopting international standards and meeting the specific needs of the institution. The CORE Next Generation Repositories Working Group defines a next generation repository as managing and providing access to a wide diversity of resources, being resource-centric, being networked, being machine-friendly, being active, supporting versioning, commenting, updating, and linking across resources. In the first instance, our DSpace repository will manage and provide access to the wide variety of publications deposited via symplectic elements, as well as digital theses and published datasets deposited directly in DSpace. The library manages both systems, and we use elements as the primary deposit mechanism for most outputs that are then pushed to the repository. We hope to push deposited DSpace datasets to elements, allowing elements users to link to DSpace datasets at the time of deposit. When it comes to non-traditional research, such as creative works, Elements does not provide the discipline-specific metadata that reflect researchers' work out of the box. It is, of course, technically possible to create a more flexible and custom DSpace submission form for NTROs, and these items can still flow into Elements for reporting purposes. But the reality is that users prefer to deposit through one system only, Elements, and the potential of better metadata for NTROs is secondary to user preferences. Getting users to use DSpace to deposit datasets will already be our first challenge. The next generation repository is resource-centric, making resources the focus of its services and infrastructure. Configurable entities are a new item type in DSpace 7 that allows for complex linked relationships between items. DSpace's entity model makes it possible to configure files as entities, turning each file into a separate resource with its own permalink. While we considered this, we did not think it was practical and user-friendly to have a separate item for each file. To allow the file to stand by itself to some extent, albeit for human consumption only, we decided instead to have on-the-fly generated cover sheets for files, which will include bibliographic and reuse information. And we expect that even if users are downloading a file directly from, example, Google Scholar, the cover sheet will be generated. The next generation repository is a networked repository. While there will be plenty of links, including bidirectional links between the repository, the UNSW reporting system, and the wider scholarly landscape due to technologies like APIs, OIPMH, and structured machine-readable metadata, our repository does not go as far as bringing the research infrastructure to the repository. And neither do we see the addition of commenting, annotation, and peer review in the repository as viable options for our researchers. To improve the discoverability of resources, machine agents need to understand that a scholarly object is a bundle of web resources. In the first instance, we will concentrate on the usual methods of exposing metadata and content via OIPMH, sitemaps, meta tags, and Resource Description Framework, or RDF. It's good to know that DSpace 7 supports technologies mentioned in the core report, namely signposting and resource sync, and we will eventually investigate these. Now, we are concentrating on ensuring that any object, be it organization, person, resource, or license, is described using standards-based persistent identifiers, or PIDs, and that we use core controlled vocabulary where possible, since this will aid interoperability and, in the long run, discoverability. While our repository won't be supporting commenting, it will support versioning and linking across resources. Linking across resources is achieved by DSpace 7's entity model and allows users to discover related research outputs. The three entities we configured are organization units, datasets, and publications. This allows relationships to be configured between these entities. For example, a journal article can have a relationship with a dataset, and either or both can have a relationship with the Faculty of Science. Originally, we had two levels at the organizational unit level, parent or faculty, as well as child or school. This would have allowed a relationship between faculties and schools, and ideally help us manage the life cycle of faculties and schools. However, managing the life cycle, for example, schools splitting, merging, or changing names, proved too complex with this model, and we decided to remove the child or school entity and only keep the parent or faculty entity. The complexity was due to the user need of wanting statistics at school level, but managing statistics during the life cycle of a school is pretty much impossible. If you split a school into two schools, where do the stats go? This presentation is a very limited version of UNSW's evaluation and design decisions, so I invite you to reach out to me at any later time. Thank you.
I guess we'll still thank Tanya for her presentation, even though it is pre-recorded. We are pretty much at session end time, but if anybody is very, very quick in putting in a question, we might have time for one. I believe that's it. I don't really have a question or comment, but it's just it's interesting to see the perpetual issue of organizational structures changing. It seems to be something we're all grappling with. Right here, there have not been any more questions arriving, so we'll close this session, and there's about a 4-minute break before this Zoom room moves on to presentation session number 8. Thanks, everyone.